All right, so let's take a look at some examples. So we've got this alkyl halide with our reagent, and we want to know what the major product is. So if we take a look at this alkyl halide, we'll notice it's primary. And then if we think back to what we said about primary ones, we said SN2 is the major pathway unless we have a bulky base. And so in this case, right, so primary says probably SN2 or maybe E2. And then we take a look at our base right here, or our nucleophile. And so this is a strong base slash nucleophile, but it's not bulky. And so since it's not bulky, it won't go this E2 pathway, it will go this E1 pathway. And so then we say hydroxide is our product, and that this proceeds through an SN2 pathway. What if we wanted it to go through an E2 pathway? Right? Again, this is primary. So we say SN2 is favored, but E2 is also possible. Well, what we could do is use a strong, bulky base. So something maybe like DBU. Right? This is a strong base only. It's not nucleophilic, and so this will then cross out this SN2 pathway and only go through this E2 pathway to form our alkene. Another example here. And so here we have a tertiary alkyl halide, and so tertiary we're thinking SN1 can occur, E1 can occur, or E2 can occur, right? And so remember, for this E2 reaction to occur, we need some kind of strong base. And so if we think about this guy right here, this is a weak base, but a strong nucleophile. And so since it's a weak base, we can eliminate out the E2 pathway. And since it's a strong nucleophile, that'll suggest the SN1 pathway. And so we'll have a substitution product here that goes through the SN1 pathway. Let's take a look at another example. And so first thing we're gonna do is take a look at our substrate. We realize that our substrate is tertiary. And so again, that means SN1, E1, or E2. We take a look at our reagent. We have a weak base slash nucleophile. And so that'll cross out our E2 pathway. And so now we have to choose between SN1 and E1. And in real life, obviously, we're going to get a mixture of these two. But in this case, we've added heat here. And so heat will prefer or favor the elimination pathway. And so we'll say that our major product here is the E1 pathway. And we will get the more substituted alkene. Let's take a look at another example. And so here we have a secondary alkyl halide. And so that tells us any one of them are up for discussion, right? It could be SN1, could be E1, could be SN2, could be E2. And then here we have a strong base slash nucleophile. And so that eliminates out the SN1 and the E1 pathway. And so now how are you going to choose between SN2 and E2? Really, you can't, right? This question would be classified, what I would say, not really a fair question, because both of them are going to occur. Which one's the final product depends on kind of your conditions. So how could we make this question kind of more fair? One thing I could do is I could tell you that under these regular conditions that the SN2 is the major product. Oh, my bad, the E2 is the major product. and I could ask you why. And so you could take a look at this compound and realize that this is indeed secondary. But remember, when we think about SN2 reactions, we also think about what else is attached to the molecule. And in this case, we have this cyclohexane, which is very big. And so there's a lot of steric bulk that will disfavor the SN2 reaction. Remember, we did an example where we had this one being a primary, but because of this tert-butyl group here, the SN2 pathway didn't actually occur, right? So that's one way to make the question fair. Another way would be to give you some more information. So let's say that we now do this in a solvent of DMSO. If you think about DMSO, DMSO is going to be polar aprotic. And so this will prefer an SN2 pathway. And so then we would say that this is the major product. Another way we could do this for a different product is we could say sodium hydroxide again, but now we're going to heat it. Remember, we said when we heat, we're going to prefer the elimination. And so in this case, we will say that we're going to go through an E2 pathway. And our base in this case is not bulky, so we'll form the more substituted product. One more example. Here we have a tertiary alkyl halide, and so we can say SN1, E1, or E2 can all occur. And then we take a look at our reagent, and we see that we have a strong base. And that strong base will then favor the E2 pathway. And so your final product will be here. And so you can see these questions can get quite a little bit tricky. You want to kind of know this chart pretty well and understand how to use this chart. Depending kind of which source you're reading from, these kind of qualifications of the heating and the solvents, they may or may not be given as much emphasis as is in this course. In real life, you'd actually have to do the experiments to see what happens. We're just going to use these to help simplify the course a little bit. And then, of course, as you're doing all of these problems, don't forget your stereo/regiochemistry. So remember that SN2 pathways cause an inversion of the stereocenter. SN1 pathways racemize. The substrate due to the carbocation intermediate. The E1 pathway will always give you the Zaitsev product, which is the more substituted one. And then don't forget these SN1 and E1 pathways can also undergo rearrangement. And then the E2 pathway can give you either the Zaitsev or the Hoffman product. Right, the Zaitsev will be favored with a non-bulky base, and that will be your more substituted alkene, and the Hoffman product will be favored by a bulky base. And that will be your less substituted alkene. And then also don't forget between E1 and E2, the trans is better than the cis if it's possible. Remember that the E2 reactions must occur with anti-periplanar hydrogens and leaving groups. And so there's a lot of information here. The key really is to practice. And I'll try to give you plenty of examples.